Let x be a discrete random variable taking values in the set of positive natural numbers. We are asked to find the value of little x such that the probability of x equal to k is sine of x to the power k. In fact, x is a discrete random variable taking values in the set of positive natural numbers. We know that the sum of all probabilities should add up to 1. Then, the sum for k going from 1 to infinity of sine of x to the power k should be equal to 1. The summation of the probability of x equals k, for k going from 1 to infinity should be equal to the summation of sine of x to the power k for k going from 1 to infinity. This implies that, we factor sine of x out and we see that the sum of probabilities is equal to sine of x times, the summation of sine of x to the power k, minus 1, for k going from 1 to infinity. We rearrange the indexes. And see that, the sum of all probabilities is now equal to sine of x times, the summation of sine of x to the power k for k going from 0 to infinity. This is in fact a geometric series with ratio equal to sine of x. As a result, the sum of all probabilities is then equal to the fraction sine of x over the quantity 1 minus sine of x. Consequently, we should solve the equation sine of x equal to 1 minus sine of x. This equation is equivalent to the equation sine of x equals 1/2. The final solution is, x equal to pi over 6. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration, and many other calculus-related topics such as probability and differential equations.